Welcome. Thank you for joining this webinar. This is surrounding the topic of data interpretation for wind turbine oil analysis. I'm with Fluid Life. My name is Josh Walkup. I'm a Fluid Life account manager. I've spent 4+ years working with owners and operators in the wind industry specifically. I've worked with companies like Danish Wind Power Academy, that was a professional training provider on different platforms, the main three like Siemens, Vestas, GE. So different technologies with different designs in mind. And so I've had a lot of emphasis with Fluid Life on the wind industries, industrial plant applications, and the oil and gas industries. So this will be a general look at wind turbines specifically from a lubrication standpoint. But one thing I do want to emphasize before we get started here is the onus and the level of importance on oil analysis is just a part of the total equation when it comes to managing equipment. So one thing you always want to keep in mind is you have to look at your ancillary data, whether that be vibration, real-time monitoring stuff, or having a prognostic mindset. And instead of just monitoring things as they occur and diagnosing, treating it kind of like what you would do with medical procedures, and say you're getting a colonoscopy before 50 years old to prevent anything later down the line. So that's just some emphasis we want to place. Of course, we're going to talk about data interpretation, the process, and some general stuff about wind turbines as a whole, but just wanted to throw that out there as well. We'll have a Q&A session at the very end here. If you can go ahead and refer to your little dashboard, there should be a chat section where you can throw questions at the end of the presentation or as they come up, and we will try to address those. Of course, if we run out of time, we can go ahead and get you an answer following this. I have all of your guys' email addresses for attendees that have shown up today. So no problem. If we can't get to everything, I'll make sure to personally respond to you guys later on. So proceeding on, before we jump into anything too deep, let's talk about the data interpretation process. We usually see it as a 3-step process that starts with interpretation. So when you're reviewing results, seeing the questions that arise, assessing your knowledge of the situation at hand with the equipment, and then seeking out additional perspective. So general questions that come up would be surrounding the actual results themselves, the numbers that are reported, the flagging that is generated on a report, and the general comments that are left on a report. And then following that, just knowing and assessing what's going on site. So that could be the oil service, could be the component's age, it could be any recent repairs or problems. Say that you just swapped out a gearbox and you're seeing a whole bunch of copper, a whole bunch of zinc in your results, but it could just be, break and wear and leaching of the copper kind of components inside of the gearbox. So those are things that you would want to take into account before doing anything. And then the last part is seeking out additional perspective. So that could be from the lab side, like somebody like us. It could be the equipment manufacturers, or it could be the oil suppliers and formulators. There's also reliability teams, engineering groups, other internal folks that have some experience, and then also your peers in the industry, other end users. Those tend to be the places that you want to seek perspective from. Then there's the decision stage, right? So that's essentially just weighing your options and making the call. What do we do with what we have now that we have assessed some of these things? So that brings you into the response stage. And, there's different tiers. You almost want to have a sense of triage, like with a hospital, what cases and what scenarios require a response and what requires an action. So of course, in this process, you can ignore results, depending on the severity, depending on what kind of protocols and SOPs already exist in your infrastructure. But then there's other things you can do. So we've already talked about gathering perspective. Then there's the monitoring aspect. That's where you want to basically see what kind of frequency and basis that you're doing testing and what kind of testing you're doing, and see if you need to make changes to that. Maybe you need to add another scheduled interval as far as sampling, or a drain and flush interval, shortening those things up. And that's tied directly with inspection and repairs as well. So the last thing there, say you've already gotten to that stage, it would be improving the program as you see it. So there's different projects you could do. There's flagging optimization, there's seeking out training, there's creating new process mapping procedures, a bunch of different ways you can address that. Next, I just want to get into wind turbines and a quick overview of how wind turbines work, right? Some of you guys may not have, end user or domain knowledge. So in a general sense, we're just going to talk about what's a wind turbine and how does it work, right? So basically, you're just looking at a tower with a nacelle and a hub with some blades on the end of it. It's going to turn kinetic energy, in this case wind, into electricity using the force from the blades. So the wind is going to flow across the blades. Air pressure on one side of the blade decreases, and that's going to create two types of force, lift and drag. And then that lift is going to be greater than the force of the drag, causing the rotor to spin. The rotor is going to connect to a generator, either directly, if it's a direct drive turbine. So that would be a permanent magnet generator. But usually what we're seeing, especially onshore in America and smaller megawatt nameplates, they're going to have a drivetrain. So that's a shaft and a gearbox that speeds up that rotation and allows for a smaller generator than the ones seen in direct drive turbines. And essentially the rotation of a generator is going to create that electrical power. It's going to feed into the grid. Some things to note about wind turbines is they do operate on an intermittent basis. They are constantly in start and stop modes. So the gearbox has multiple stages to handle the different types of speed, the different types of forces. And a lot of these things can be affected by the amount of load and the variation of the load, because wind isn't perfect. And then it creates, settings for vibration and increase in temperature and fluctuation in wind speeds and direction. So there's some things that are set in place to counteract that, like the yaw system that's searching for the wind direction, the pitch system, which is trying to get the right amount of air pressure on the side of the blade. And then the last thing here is just that wind turbines tend to have long life oils in them, and they're serviced in maintenance cycles, which happen in low wind season. Usually you're seeing service cycles on a biannual or an annual basis. So for this presentation, we're just going to talk about these two types of oil in a wind turbine. Of course, there's other systems inside of a wind turbine. There's electrical systems. There's also grease applications in wind turbines, but we're just going to focus on the main two that you tend to see. Number one being gear oil in the gearbox that we discussed before. In both of these pictures here, you can see the gearbox itself. This is one example of one. There are multiple sub-suppliers that manufacture. And then in this picture inside of the nacelle here, you can actually see the whole shaft going from generator, rotor to stator. So these two systems, you also have the hydraulic oil. It's a pitch system, and also can be a braking system in design. So starting off with the first one, it's types of gear oil in a wind turbine. What you're typically going to see is enclosed gearboxes in the nacelle of wind turbines. Like I had discussed before, there are direct drive turbines as well, but this is what you tend to see onshore in the US specifically. To keep these systems operating at maximum efficiency, you have gears that must be appropriately lubricated with a suitable viscosity. You're looking at industrial grade gear oil formulated with the right, performance credentials. So recently there's been a drive to develop advanced gearboxes that are specifically designed to meet demand for higher power output. And wind turbine gearboxes are significantly affected by the harsh operating conditions that we discussed before. So that would be, your load variation, vibration, temperature, and fluctuation in those factors. There's also issues like foaming and water ingression that can be introduced to a geared application system. What you're going to typically see as far as oils in these gearboxes are synthetic polyalpha olefins, or PAOs, and I'll refer to them as PAOs for the rest of this presentation here. These are suitable for wind turbines because they can sit for a longer period of time and keep a good operating temperature. That's compared to your old school mineral-based industrial gear oil. So as mentioned above here, some strengths of that are high thermal oxidative stability, you have a high viscosity index, low volatility, which is different than seeing something like a specific blend of diesel fuel, for example, may have different volatility characteristics. And then there's good flow properties at low temperatures. It's not seen as a toxic, chemical in this application, and they have high compatibility with mineral oil. So if you're swapping suppliers or changing things out, it's usually less of a concern with PAO gear oils. Some of the weaknesses is its limited biodegradability. We're talking about the wind industry specifically here, right? So that's obviously a topic at hand and things that need to be discussed. And a big part of wind and the push for wind as a whole, of course, is being responsible to the environment. So that's why it's a good thing that these oils sit in the system and circulate in the system for quite a while, right? You're looking at lifespans that tend to be anywhere between 3 to 7 years before doing a full drain and fill of new oil. So it's encouraged to top off with oil and purge out, of course, when needed, and monitoring some of the contaminants, but it's pretty good for a pretty long time. So here's just a chart talking about some of those benefits. And then the last weakness here that we should discuss is there's a risk for seal shrinkage, right? So in all sealed components, there's going to be rubber, there's going to be O-rings. There are things that are prone to degrade with the introduction of lubrication. So that's something to keep in mind. That tends to be a general issue with different applications and different technologies, but specifically in gearboxes and hydraulics, I'll also mention that can be an issue, right? So some things you want to check for with a gearbox is micro pitting, white etching cracks that appear on the bearings surrounding the gearboxes, and that could amplify and lead to tooth breakage and other catastrophic failures over time. If you guys aren't aware, gearboxes are pretty expensive. They can range around like $250,000, and then you have to talk about mobilizing a crane. Most sites don't have that stuff ready to go, and they also usually don't have a bunch of gearboxes lying around in the shop floor. So one part of the equation, of course, is having that non-firefighter mentality. You're analyzing problems both in real time, but also in preventative measures. So that's staying on top of maintenances, that's having other data to support your oil analysis, whether that be boroscoping or vibration data, as just some examples there. So next we have types of hydraulic oil in a wind turbine. Same situation here. PAOs are also used in hydraulic systems to maintain the performance for longer periods of time. Same issues arise where you want to keep an eye on temperature and make sure that it's pretty fairly consistent in operation states. As mentioned before, wind turbines perform on intermittent basis, so they have a lot of start and stops depending on operation state parameters. Wind speed is going to affect its cut in and cut out of operation. There's also market factors that dictate when turbines are operating. Just as an example, you have low wind seasons, high wind seasons, and then of course you have different parameters. Say you're in Texas and there's the ERCOT market and you're subject to spot market pricing. Some of those things affect this, so you have to have lubrication in there that can handle that. Now the difference in hydraulic oil in a wind turbine versus gear oil is obviously with its different application and different volume of the reservoir of the system. They're going to have different viscosity. So viscosity, just a very general explanation of that, its flow rate and how it handles shearing and temperature changes in operation. So this tends to be a much lower viscosity. You're going to typically see a 32 centistoke viscosity at 40 degrees Celsius, whereas in a gear oil, it's 320 typically. Another thing to note is this hydraulic oil is pretty flammable and it can be subject to pressure loss and seepage. Just a general understanding of how pitch works. You can think of it as like the muscle for wind turbine blades. So some of these are electronic driven or electric device driven, like GE turbines, for example. But most other platforms that are even sub 2.5 megawatts are going to have a pitch system on them with a hydraulic setup. So these hydraulic pitch cylinders, which can be seen right there, are inside of that hub there, and they're going to adjust those blades. These can derive a large amount of energy using comparatively thin tubes and hoses. Key elements of performance can be tough resistance to volume reduction under pressure. And, we're same thing here. We're made of oils and additives that transmit the power smoothly and effectively, while simultaneously performing as a lubricant. It can also have a cooling factor. It can reduce wear, rust, and corrosion in hydraulic equipment. So not only the assembly for pitch, there's also brake control assemblies, and they work pretty much the same way. As we know about hydraulics, they displace a lot of energy in a smaller system than different design methods. So that's kind of why they're used so heavily in wind turbine technology, as wind turbines are kind of derived from a hodgepodge of industries, including aviation, right? So hence the blades on the end there. So now I just want to show you guys what us as Fluid Life would consider a basic kind of baseline wind turbine testing criteria. So we have multiple tests that we can run as a lab, but these are some that we pertain to any wind owner or operator. We would recommend this. There's also, of course, additional testing. For example, there's foam testing, demulsibility testing, and some of those other things that you can do, but this is the basic stuff. So starting with spectrometry, it's a ICP elemental instrumentation that you run, and you get all the element breakdowns. It helps you determine what your additives are and the breakdown of contaminants and stuff. We'll go ahead into detail with all of these different tests and what they mean as well. The next one's viscosity and viscosity index. The other tests would be water percentage by Carl Fisher test, oxidation by FTIR instrumentation in hydraulics, total acid number, isoparticle count, and total magnetic iron, or the equivalent of what other labs would use as a PT testing. So let's start with spectrometry by ICP Instrument. So wind turbines are serviced and sampled less frequently than equipment in other industries, as we've discussed multiple times now. That leads to a challenge, specifically in trending data by the time the oil is, out of service and it's bad. You're going to look at 1, maybe 2 sample points and 1 or 2 samples per year on this equipment. So the big challenge with oil analysis as a whole is that you don't have a lot to go off of. There's not a lot of data points to refer to. There's not a lot of perspective to gain or draw, other than, catastrophic failure type situations. So the main focus being on oil analysis is not something I would just purely recommend. I think it should be a combination of different methods in order to get the best results, right? So the main focus as far as spectrometry results is going to be monitoring the presence of your wear metals. Obviously, gearboxes are prone to showing up with iron and copper. And then there's also changes in additive levels. So if you look above at the image placed at the top here, you're going to look at different wear metals. There's different additives that show up on these reports. And just seeing what your baseline is, that would be this green line here. And then over time, just monitoring and seeing the changes and fluctuations of such. A thing to keep in mind as well with these elements that are reported in parts per million is that wear particles are limited to around 5 microns in size, right? So what is a micron? That's a unit of length equal to a millionth of a meter, and it's used in a whole bunch of technological and scientific fields, oil analysis being one of those, right? So with this, understanding that other wear metal analysis tests can be used to confirm the presence of metals, those being things like analytical ferrography or SEM testing, scanning electron microscope, as you may have heard of it. They're going to be better at identifying larger particle sizes, right? So this is going to catch all the small stuff and the concentration of small stuff, but it may not tell you the nature of the wear. It may not tell you the size distribution, and some of the other things like spotting alloys is going to be a little bit more difficult. So that's where, gaining additional perspective and having end user knowledge and looking where root cause is a big deal, outside of just, oh, I have a report, it's flagged, send it off to my engineering team, Another thing to keep in mind is different elements are going to serve as additives in your gear oil, your hydraulic oil. So there's detergents, there's antioxidants, there's anti-wear additives, there's anti-foaming additives. There's a whole bunch of stuff that is concentrated in these formulations, and suppliers are also prone to changing their formulation without telling you. So it's really important to get your baselines and your oils from your bulk oil tested repeatedly as well when you are getting more supply in. The next test we can focus on here is viscosity or viscosity index. So viscosity, like I stated before, is a measure of a fluid's resistance to flow. This is probably the #1 physical property that people look at when it comes to looking at oil suppliers and looking at testing. They want to see what the viscosity looks like in practice. It should remain pretty consistent over time, and it's definitely something you want to keep an eye on over time in wind or in any industry, really. Viscosity is usually affected by the presence of water or other contamination, and then it's also prone to thermal and oxidative degradation. So heat and age are going to affect viscosity, two things that could be pretty fairly regularly introduced in operation of the wind turbine. So looking at a fluid with a high viscosity, you're going to resist motion because it has a lot of internal friction when in motion. And a fluid with a low viscosity is going to flow easily because it offers less friction when it's in motion. Something to keep in mind here, do what's recommended as per your guys' specs with your operation manuals, and your lube providers make sure they have wind turbine specific application for gear oil and hydraulic oil. Looking over at the little report screenshot here, you can see that we have our viscosity reported in 40 degrees centistokes and the 100 degrees Celsius centistokes, and also the viscosity index. So your viscosity index is basically just showing you how it holds up throughout that temperature fluctuation. The 40 degrees is kind of your sitting baseline of your oil versus the 100 degrees Celsius, which would be as it's starting to run up in operation, right? So this example here would show hydraulic oil. The new oil reference was at 29.4 centistokes, and the ones in practice are a little bit thicker than that. It's usually, told to be 32 degrees or 32 centistokes at 40 degrees Celsius. So no problems here, no flagging showing up on that report for that reason. Next, we're going to talk about water contamination. So in a perfect world, water is really good at displacing heat, but the problem is it's super corrosive on its own, right? So some issues with water contamination, especially in systems that need to be dry, like a gear box or like a hydraulic reservoir system, you're going to accelerate your oxidation and you're going to promote corrosion with the introduction of more water. It's going to displace your oil film, so all the lubrication properties, because water and oil generally don't mix and have different chemical properties, different density properties. That could actually push your lubrication away from all those moving parts that need something in between them to not chip off. So this can diminish not only the oil film or the effectiveness of lubrication itself, it could also diminish the effectiveness of the additives within. So like those detergents, like those antioxidants, like those extra pressure, wear additives, all that stuff can be affected. And of course, this is going to cause some clogging. It's going to get your filter elements kind of out of balance, out of whack, and you might have to replace those more frequently. And the crazy part about water as well is when you start getting it really amped up in speed, it can be an abrasive element as well. Just some things to note, gearboxes are going to show a little bit more water in results usually, just depending on ambient environment, different sampling methods that are used, your frequency of draining the reservoir and topping off. Some of those things can affect the ingression of water. I've talked to wind turbine sites, and some of them have had hurricanes occur nearby site, or they live in humid. The turbines live in humid environment, and that's going to lead to a higher spike in water ingression. Your hydraulics have a higher standard of cleanliness, so they should show less water. One thing to kind of keep track of is these can be reported in percentage of water, unlike the rest of the report, which tends to have more ppm related reports, but it's a really easy conversion. For example, 1 ppm of water is 0.0001%, and there on forward. So if you're looking at 100 ppm, it's 0.01%. Water can be present as free, as we're talking about with different chemical properties and oil and water not mixing, but that doesn't necessarily mean it can't be dissolved or what we call emulsified, where it mixes in a little bit. So keep that in mind. Free water is pretty easy to spot because it'll accumulate at the bottom of the loop system, but sometimes it can mix in with your oil and degrade the ability for the oil to work the way it's supposed to. All right, oxidation. So this is essentially a chemical reaction between oxygen and the oil itself. Oxidation happens with multiple things. A simple example in the real world of oxidation is when you see the presence of rust. Say you got your kid's bike and you're seeing the metal portions with some rusting on it. That could be a sign of oxidation. So this reaction is going to form insoluble deposits within the oil. More abrasion is usually not a good thing in most systems, right? Oxidation is a pretty good indicator of not only the degradation of the oil, but just the age itself. It's heavily influenced by temperature, it's heavily influenced by contamination, it's heavily influenced by how often you're draining it and topping it off. And accelerated oxidation or prolonged use can lead to an increase in viscosity, and it could also lead to an increase in acidity or corrosiveness. So it's something to definitely keep an eye on. And it's pretty common in wind turbines when you're seeing things that sit for 7 years in the system, and sometimes even longer, depending on if you're having trouble. I mean, we're talking about issues globally right now around sourcing supply, around getting oil from suppliers. So some sites do what they have to do, and they let it sit longer than that, even when it's past recommendation from oil suppliers. And you're going to see elevated oxidation in those cases. So total acid number is the measure of concentration of acidic byproducts due to additive depletion, contamination, or when you're seeing oxidation for a long time, right? So one thing to note here is there's a distinction between total acid number and something like an IQH test, right? So acid number is not the measure of the strength of acidic products. That would be something like the IQH test. Once again, you're just looking at concentration. So it doesn't necessarily speak to how corrosive in nature it is, but it is showing you that there are corrosive elements present in X amount. Acid number and oxidation usually show some sense of correlation. So if we're looking at total acid number here, usually if you have elevated results here, you're going to see some elevated results in oxidation. Now, this isn't always the case, but it's fairly common. And it's pretty common to see this happen in wind turbine hydraulics, right? There's not a lot of disturbance in hydraulic systems and in the reservoir where you're testing from. They have long drain intervals, so you can see this stuff showing up. It also happens in gearboxes as well, but it definitely happens in hydraulics pretty quickly. Most wind turbines are going to have additive packages in the oil that are going to have a bunch of acid protection, but over time, as we know, not only does oil degrade through oxidation, so just natural course of its life, but you're also running through operation, you're introducing contaminants, you're doing a lot of stuff that will lead to depletion of additives, whether that be they're consumed over time or they drop out naturally just based on the formulation. So isoparticle count is pretty simple. It's basically a number in 3 sections in the code is talking about how many particles in that size distribution are present. So for example, you have this 20, 18, and 15. There's a size range of the 4 micron size particles that classifies as 20 for 5,881. and then so on and so forth in the 6 micron and the 14 micron size distribution range. So when you see an increase in ISO test results in your ISO code, you're essentially looking at more general contamination. So there are recommended amounts from your lube supplier, and there's also recommended amounts for most manufacturer suppliers that offer ISO code at the very. When you're looking at gear applications, they tend to have a higher amount, a higher concentration, because the operating conditions are different than the hydraulic. But as a general rule of thumb, you should have the cleanest oil, the driest oil possible in any system, no matter what. So, looking at these, when you see a 20, 18, 15 jump to 21, 19, 16, it means you're doubling in every category there in the amount of particles. So when you see the difference between the 19, 18, 15 just before the 2019, 16, that's a little bit of cause for concern, because it's literally doubling over in every size distribution. Now we're on to total magnetic iron. So what we call total magnetic iron, or TMI, is the equivalent of a PQ test. It's just reported a little bit differently, so we can talk about that a little bit. But TMI is designed to measure the degree of ferrous wear metal contamination in an oil sample. Right? So ferrous metal is a metal that contains iron. Your steels, your steel-based alloys are ferrous metals. So when you're looking at things that are non-ferrous, that would be metals like aluminum, your copper, zinc, tin, and so on and so forth. So the TMI, unlike ICP spectrometry, which we were discussing before, it's not sensitive to particle size. So this is a good way to kind of have a check and balance against your spectrometry results. When you're looking at results in general, you don't want to look at them in a vacuum for each portion of the report. You want to take them holistically, and you want to understand the importance and the meaning behind each test so that you can compare and contrast what that may mean for the system as a whole. So that's the direction I'm taking you. That's the way I want you to think coming out of this, is looking at things holistically and looking to your other data to support. So just going back to TMI here, TMI provides early detection of your abnormal wear conditions, your imminent equipment failure. It's really good at screening for things that can trigger advanced testing. Like mentioned before, there's analytical ferrography or scanning electron microscope, or SEM. Those are other ways that you can dive a little bit deeper than just this one figure here. You can get pictures, distribution, sizing, classification, some things that are a deeper look at the nature of what's going on there. But this is a great starting point. If you're looking at TMI in your spectrometry, and if both of them are increasing and they're congruent with one another, it's likely that you're going to be seeing a bunch of small particles that are being generated, bunch of small ferrous particles, I should say, that are being generated. And then if it's increasing and there's no change, or if there's a decrease in your spectrometry results for your ferrous values, this suggests your large particles are being generated, which indicates an abnormal level of wear. So there's different classification of wear as well. You're sliding, you're cutting, so on and so forth. And this would be a great way of getting to that step there. So concluding the kind of test rundown here, just wanted to display to you guys how can Fluid Life as an organization help with those things. So number one would be the lab service portion, right? We have multiple labs. We have 2 in Canada, and we have 1 in the US at its current state, and we're actually building one in Irving, Texas, right outside of Dallas, as we speak, and it should be ready to go next month. So we do have lab service capability. With those things, you can evaluate your current testing and see if you need to upgrade the testing packages or add any, a la carte testing as they arise, as issues come. We also offer private training. So obviously we're doing a webinar here. This is a little bit more impromptu, but we have formal training both on our web portal for everything, and then we also have your informal training as part of my scope as an account manager. I pick up the phone, I answer questions, and I do a lot of data interpretation, go over results. That's a big part of my position here. So having some end user capability that is deployable to help you guys out is a big part of our business operation, and we want to continue to do that. And that goes part and parcel with the reliability services, right? So we do benchmarking, we do audits, we visit sites and see if procedures need to change. We can do improvement programs, we can change flagging, we can add different types of analysis, different tiers of service that can help you guys strengthen your oil analysis program as a whole. And that concludes my webinar presentation. Does anybody have any questions they'd like to type in the chat at this time? You can go ahead and we can do a quick Q&A, and then we can conclude this presentation as a whole and get you guys out of here at 10. So Jay had a quick question just saying, will there be a recording sent out? We do record these, we do publish these. Of course, if you have any additional questions or if you are a part of a program with us already, you can reach out to me directly as well to do any support outside of the scope of this. But yes, we will have a recording. I am not positive if we'll be sending it out, but it will be published on our website at www.fluidlife.com under our resources tab, and it'll be there, in perpetuity. So if we don't send you a personal recording, it will definitely be published thereafter. Any other questions, folks? So I have another question. It says, what separates Fluid Life from others? So where I would go in the direction of answering this question is essentially stated right before my conclusion of the presentation. We have a team of account managers, much like other lab services and providers. But the difference is I have experience with wind turbines and with the industry as a whole. As far as our business executives and our leaders, we have folks that have personally climbed wind turbines, have personally performed services on wind turbines, changed oil, and have also, done repairs and retrofits and know the systems inside and out. Whether that be, the GE's 1.5, ESS, non-ESS, doesn't matter. Whether it's a Siemens Gamesa 2.3, if it's a G2 platform, or if it's another variation, we can help distinguish those differences, whether that's the pitfalls of the design and the platform itself. Not to bash on any OEMs, they do a lot of great stuff. But we can talk about the things that happen in practice in real life that we've come to see, and we have some of that tribal knowledge that we can pass on to you guys. So that's what I would say. It separates Fluid Life from others in the context of wind. I have another question that says, does your company offer, for example, data integration and use of sensors? And yes, we do. We have a telematics side, I should say. It's called UCM. And essentially what you're looking at is not only unifying your condition monitoring, which is what UCM stands for, Unified Condition Monitoring, but you can not only pull that stuff into our system through our MyLab portal, but we also are now offering ways that you can pull that ancillary data that we had discussed before. So we are working on telematic modules that can take vibration, and I can link you up with the folks that need or that have all the information that you need regarding that. And another question here is, could you do this type of training at our locations? We do in-person training, as shown on this last slide before here, where we have programs like our MLT or our MLA, your maintenance and lubrication technician, maintenance and lubrication analyst programs. We have certified and non-certified courses. We do online training and in-person training. We have a trainer named Drew McRae. He's actually pretty much booked out till November this year, but we definitely keep him busy, and he goes on site in the central locations and posts training all the time. Another question says, you mentioned a lab in Texas. Can you share if you'll be having tours or a grand opening? And yes, we will be having a grand opening next month on the 12th. We do have RSVPs. I can provide you with all the appropriate information regarding the grand opening in the Texas lab. So if you guys are interested in that, just let me know and I can pass that along. Are there any other questions, folks? Do you do SEM in-house? Yes, we do SEM in-house. We have our own instrumentation. Just like we were talking about the Texas lab, we're actually adding 2 of those specifically to the Dallas lab here coming up. So we can not only perform the testing in-house and get you a quicker turnaround time, but we can opine on those results with our reliability team, as well as someone like me, the account manager role. The next question I have is, can you share on grease testing for main bearings? And yes, I can, and that's actually in my next webinar. I'm hosting another one next month, I believe on the 14th, but I will have to verify that. I will send all of you participants information on that, just as a great follow-up to this webinar itself. In conclusion, we'll go into greases, we'll talk about compatibility and properties of grease and things to watch out for and the testing performance. So very similar to what we just did here as an exercise, we'll do for grease specifically, but it requires its own topic and its own delegated time. And I think that's pretty much all the questions coming in here. So thank you all for joining today. I appreciate your time. Once again, if you have any other additional questions, you can send me an email directly, or you can email at info@fluidlife.com or customercare@fluidlife.com, and we can get you the support you need. My email is joshua.walkup, WALKUP, @fluidlife.com. And of course, if you need anything, feel free to give us a shout. Thanks so much. Appreciate it. Have a good day.